Welcome to the Code with Jason meetup. Today we're going to be working some more on SaturnCI, which I know you guys are all familiar with. Let me take a look at my most recent comment here to remind myself what we were working on last time. Okay, this comment says, the pushing and pulling works, but when we do a build, it doesn't seem to use the cached image. Okay, so just for context, for anybody watching on YouTube who is not familiar with what we've been doing recently, SaturnCI is a CI platform. It's a place where you can run your test suite. There's a problem that I'm working on solving right now, which is the builds take a long time. They take too long. Right now, my test suite only takes about 20 seconds to run, but running it on SaturnCI takes like 4 or 5 minutes. So there's quite a lot of overhead. And I believe we can get rid of a lot of overhead by doing some caching. There's a Docker build step in this test run process. And if we cache the Docker build, then we should be able to save about 1 or 2 minutes. So this comment says the pushing and pulling works, but when we do a build, it doesn't seem to use the cached image. What does that mean exactly? Let's look at this script. So when we do a run on SaturnCI, it does parallel jobs. So there's 2 parallel jobs for each build. And when a job runs, it runs this script. So it clones our user's repo, checks out a certain commit, does some Docker related configuration here. And then here's the part we've been working on recently. We pull our latest image if it exists, and then we do a build. And then after we do a build, we push what we just built. And if it's cached, what we're pushing is, if it's cached, this step is actually pointless because it's just building the same exact thing that it already had. But if it's not already cached, then this puts something in the cache that we can pull down next time. Okay, so our problem is that this push works and this pull works, but when we do this Docker compose build step, it's not using this cached image that we pulled. So we could continue to test this by doing what I've been doing, which is to repeatedly run builds and wait like 4 or 5 minutes for it to finish and then see if it worked. But that's a lot of overhead. That's a long feedback cycle. So maybe there's a faster way that we can get what we want. So just to restate the problem yet again, the pushing and pulling works, but when we do this build step, it doesn't use the cached image. And I don't understand why. So that's the problem. The problem is that I don't understand how Docker Compose build works with respect to caching. If I understood how Docker Compose build worked with respect to caching, then there would be no issue. Then I would understand why this isn't working and I could do whatever's needed to make it work. So what needs to happen is I need to gain an understanding of how build and caching works. And in part of that process, I can do some experimentation locally because I can pull images and do Docker Compose builds locally. I don't need to do a SaturnCI build in order to do that kind of stuff. So we can have a shorter feedback cycle in troubleshooting this issue, shorter than actually running builds on the platform. So let's do that. I'm not sure where I want to start, but I'll say, how does caching work with Docker Compose build? And I'm not completely ignorant. I understand some things. but my understanding is fairly vague and shaky. So I could definitely stand to understand a lot more than I do right now. Okay. Docker images are built in layers. I understood that already in at least a superficial kind of way. I understand that Docker images are built in layers, but I'm not sure exactly what a layer is. So that's kind of a mental note. It's like, what is a Docker image layer? Cache invalidation. Each layer's cache is invalidated if there are changes in the Docker file commands or in the files that are added. Okay. Okay. Um, I'm just gonna ask, what is a Docker image layer? Okay, lightweight standalone executable package that includes everything needed to execute a piece of software. Okay. Okay. I still don't really understand. So I'm going to give it my Docker file and I'm going to say explain this Docker file in terms of layers. Okay, the base layer, I kind of understood all that, or I kind of understood that already. So every Docker image uses a base image, if I'm not mistaken. And for this image, I'm using a Ruby 312 base image from Docker Hub. Okay, workdir code. This establishes the working directory on the image where we're going to be doing everything and putting all our files and stuff like that. Okay, this might not create a new layer if no files are added. Okay, I don't really understand. Copies the gem file and gemfile.lock. This operation creates a new layer as it alters the file system of the image. Okay. Bundle install. This creates a new layer also. Okay. Copy code. This command is responsible for adding your application code to the image, creating a new layer. I chuckled because I'm surprised by how many layers are being created. Seems like a lot. Downloads yarn. Okay. That's like a lot of layers. That's like 10 layers or so. Um, I mean, a little fewer than 10 layers, but still, that's a lot of layers. Okay, interesting. And I'm gonna do something. So I'm gonna pull this. I'm gonna pull an image. Okay. So when I do a Docker pull, it has all this output. I've never really understood what all this output is. And I wonder if each row here is a layer. Explain this output
Yeah,
to
was
me.
about to, was about to say, let's ask ChatGPT.
Yeah, yeah. What does each row of output represent? Okay. Uh-huh. Each row represents a different layer of the Docker image. Okay. Okay. That is interesting. Okay, so now this output's a little more clear to me. Okay, so for some reason, these layers already exist, but there's a couple layers that don't. I'm gonna let this download complete, and then I'm gonna do another poll, and I'm gonna see if it says already exists for all of them this time.
Yeah, theoretically, it should say already exists for all, isn't it?
Sorry, say it again, Sanjit.
Theoretically, it should say already exists for all of them, isn't it? Because you have already
Yeah.
downloaded, possibly. Yeah.
Yeah, I would agree with what you said. Okay, interesting. It didn't even show us all the layers individually. It just says
No,
image is up to date.
to date.
Interesting. Okay. Hmm. Okay. Now, when we do a poll when we're running a build, nothing would ever be cached locally because each build starts with a fresh machine. So it's still going to download the image no matter what. I'm just stating facts to aid the understanding process. Okay, so we're gonna do a poll and it's gonna download it every single time. That's fine. It's the build where we're looking to save some time. Okay, so now if I do if I perform a build now, what's gonna happen? Okay, it's running bundle install. Okay, interesting. So in a way, I'm not surprised, but in a way, I am surprised because when I perform this build, I would expect it to use this image that I just pulled. Okay, so take note here. Um, we're saying Docker pull this IP address, Saturn test app latest. Here we have Saturn test app, and we're saying use this image, this IP address, Saturn test app latest. So according what I was led to understand before now, if I have if I have this image, okay, Docker image ls grep Saturn test app. Okay, so see, I have this image that's tagged with this full IP/Saturn test app. Okay, I'm gonna do this to make it more clear. Cat Docker, sorry, cat Docker compose grep 146. Okay, so as we can see, this tag matches this. I mean, it matches this. Okay, so this is the image name and this is the tag. Let me just check myself there. Okay, repository and tag. Okay, so this is the repo and this is the tag. And then here's the repo and here's the tag. So based on what I understood before, my Docker Compose configuration should look to my local images and just use what I have locally. But that's not happening, meaning my previous understanding must be wrong or there's something else weird going on. So let's ask ChatGPT about that. So I'm going to show it that Docker image ls output. I'm going to show it my Docker compose file. And I'm going to say, I believe I'll show it some of this output. Okay. So I'm going to say, when I perform a Docker compose build, the build process performs a bundle install, even though I have the Saturn test app image already on my local machine. Why then is it sorry, somebody just joined the meeting. I had to click the button. Why then is it performing the bundle install step? Okay. Welcome, Azrad.
Hey, Jason.
By the way, did I say your name correctly?
Yeah, yeah.
Okay.
Just fine for me. Thanks.
Where are you located, Azrad?
I'm located in Kuala Lumpur, Malaysia.
Oh, wow. Okay.
It's 12 hours different. I don't know where you at.
I'm in Michigan.
Michigan. Oh, okay.
Yeah.
I yeah.
Yeah, I actually
First time.
I know a handful of people in Kuala Lumpur.
Oh, nice.
Hmm. Yeah, never
Yeah,
been
but
there,
first
but
time.
hopefully I can visit someday.
Yeah, yeah. Hopefully we can meet as well.
Yeah.
Yeah.
Okay, so Azrad, we're working on troubleshooting some Docker Compose, some Docker issues, some Docker caching issues. The problem is that um, my Docker caching isn't behaving the way I expect. And what I deduce from that is that my understanding of how Docker Compose caching works is incorrect. And so I'm trying to figure out, where am I misunderstanding? Okay, so I said when I perform a Docker Compose build, the build process performs a bundle install, even though I have the image already on my local machine. Why then is it performing the bundle install step? Okay, it follows the instructions specified in the Docker file. Yeah. Even if you already have an image, blah, 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 on your local machine, Docker Compose will rebuild the image if the build context or Docker file has changed, or if the build is explicitly invoked. Okay. So the Docker file definitely hasn't changed, or if the build is explicitly invoked. I don't know exactly what it means for the build to be explicitly invoked. So mental note there. Here are several reasons why Docker Compose is performing the bundle install step despite the presence of an existing image. Docker file or build context changes. Okay, we already know that that's not the case. Cache invalidation, if gemfile or gemfile.lock are changed, that hasn't happened. Okay, explicit build trigger. Running Docker Compose build explicitly instructs Docker Compose to rebuild the images according to the instructions in the Docker file linked in the Docker Compose YML, unless you specify no build or configure services to always use an existing image. Docker Compose defaults to building images if a build context is provided. Okay, I want to say this. So I think that solves the issue, but okay, look at this. If we say Yeah, so I think we just don't even need to perform the build step at all. Yeah, okay, hang on a second. Okay. So here's what I think the deal is with this. So I think we can actually just skip this build step. We can skip this build step, assuming that this pull is functioning just fine. And I'll skip this push as well. So we can skip the build step. And obviously that's going to work in the case where there is an existing image, but it won't work in the case where there's not one. But let's not worry about that yet. Let's just use the existing image and worry about the other case in a second. All right, so I'm going to commit this. Temporarily omit build step. Okay, now if that works in the way that I expect it will, then it'll run more quickly. Okay, so that's running. I'm going to set my timer on my phone for, let's say, 3 minutes, because that's about how long I would expect it to take at most. Okay, and when that goes off, I'll check back. Okay, so I did a Docker Compose build just now, and it performed that bundle install. How could I test? How could I do a test to see that I can use my... All right, I gotta get my thoughts straight here. Okay, so why are we using Docker Compose? It's because we need to have an environment where we run our tests. Yeah, so can I use this environment without performing a build first? Docker Compose run. Yeah. Yeah, okay. So I'm going to run a test using this Dockerized environment, and I'm going to see if it works, even though we have not yet performed a build. It seems to just be frozen. Interesting. So I'm going to run something simpler. Instead of saying run a test, I'm just going to run the command ls. Okay, that worked. Who knows why the test wasn't working? That's irrelevant to our concerns right now. What I wanted to see is, can we use this image even though I haven't performed a build? And let's prove this even more in an even more certain way. So if I do docker image ls grep Saturn. All right, so I'm actually going to delete this one. Okay. And I'm going to delete this one too. Just because I don't want to accidentally trick myself. Okay, so now we have no Saturn image. And my expectation is that this is not going to behave the same way. It'll either not work or it will do a full build. Yeah, it is doing a build. Yeah, okay. Okay, but I don't want to let it do a build. Okay, we still don't have the image. Instead of doing a build, I just want to do a pull. And there's my timer. Okay, so I did a pull just now. Now I'm going to run that ls again. And I expect now, yep, That's what I was expecting. I was expecting that it was just going to work because instead of doing a build, we just did a pull, thereby skipping the build step. Okay, so something weird happened here. You can see the state says running, but it has 3 minutes, 51 seconds here. I don't know what happened. Okay. So while I'm investigating, I'm going to rerun this build so we can get another sample. So in these older test runs, if we look at the event log, we can see that between the build started step and the build finish step, it took 58 seconds for this one, 59 seconds here, 66 seconds, 101 seconds, 108 seconds, 83 seconds. All right, so on that order. And then for this one, it took 0.18 seconds. Yet the total runtime was not significantly less. So that's interesting. So let's try to figure out why that might be. I think I'm actually going to pull up an Excel spreadsheet here. Okay, new sheet. Okay. So I'll copy all these. Let's see if they get pasted neatly into the cells. They sure did. All right, I'm going to kill this column. All right, so this is without build. And then I'll paste this one too, because this is also without build. Oops. Oh, for whatever reason that didn't work the same. What if I paste it somewhere else? Okay, well that's unwelcome. Let me try that again. Okay, for some reason that worked. Okay, I'll delete these columns. Okay. Without build 1. And we'll say without build 2 right here. Okay. And then we'll grab a couple that did have the build. And I'm actually going to grab the relatively older ones before we started doing this push and pull business. Okay, I'll get rid of these. Grab this one. Okay, and this should be enough for starters. Okay. So I'm just going to go down each row and look for things that are significant. So job machine ready, that varies a bit. Nothing stands out to me. Repository cloned, nothing stands out. Image build started. That's a bit different. So you can see 19 seconds and 32 seconds here, whereas we have 0.9 and 1.02 seconds here. So this is a lot more here. And I'm just gonna do this. Okay, that's like too hard to read. Hang on. There. Okay, sorry. This is like totally not that important, but I want to pick a good color. Okay, I'm just gonna make it yellow. Okay, and then this is much different. Prescript started, not much different. Prescript finished. For some reason, it only took 36 seconds one time, and these were all about a minute, but I don't know that that's significant. These are all about the same, and these are all about the same. So it looks like the significant difference here is that the build step takes much less time without the build, but then the clone step takes much more time. Sorry, I said that wrong. The build step takes much longer when we're actually doing the build, not surprisingly, and it takes much less time when we're not doing it, but the clone step takes much more time when we're not doing the build than when we are. But I suspect that this is actually giving us misleading information. I don't think we're really seeing the clone step. This is just the difference between when the clone step happens and when the image build started step happens. And something that happens in between is the pull step. So I think this like 19 and 32 seconds, I think the reason that we're seeing some time there is because it takes a bit of time to pull the image. All right. But still, 19 seconds is 80 seconds less than 100 seconds. So we should see it taking, on average, about a minute less than it used to. Okay, that time it passed. I'm going to rerun it several times because there is some variance in the run times. I'll rerun it like 5 times. By the way, a feature I plan to add soon, I don't know about soon, but a feature I plan to add is a thing where you can just easily say like rerun it 5 times or rerun it 10 times or something like that. Because that's something that when I'm diagnosing flaky tests, I find myself needing to do somewhat often. Okay, so let's see. We'll kick off one more run. Okay, so I'm going to go back to these older ones. For some reason, it used to take a really long time. Like we can see this one is 6 minutes and 9 seconds, 6:23, 5:51. And then more recently, it's been 4:38, 4:29. I don't know what accounts for those. But then not that long ago, we have 5:11, 5:23. So on average, up to 5 minutes or more. And then this one was only 3.5 minutes. So that seems better, but there's enough variance in the older runs. Like we can see this old one, that's 3 minutes and 37 seconds. And that I don't think is because we actually made any improvement. That's just within the range of our normal random variance. So we can't take just one instance of the test suite running in as little as 3.5 minutes and deduce from that that we've made an improvement, because again, that's within the range of random variance. We will have to run it several times. And if and only if we see that the average is now lower, can we conclude that we've made an actual improvement? All right. So let's pause for a second and assess what we've done and what we're going to do next. So we took the job script and we omitted the build step. Instead, we can just do the pull. And so instead of taking the minute and 40 seconds that the build takes, we can spend more like 20 seconds pulling the pre-built image. So that's great. When that works, then that's great. But the image isn't always going to exist. The first time we ever run the test suite, there's going to be no image. So we need to make it so that when there is an image existing, then we use it. And when there's not an image existing, then we do the build. We may or may not have to do something explicit for that. It may be that Docker can just be smart enough to handle that for us. I don't know. But that's a case that we're going to have to take a look at. So that's one thing that we're going to have to address. Another thing we're going to have to address is when the cache goes stale. So right now, if we were to, sorry, I was going to say something and I realized I might be wrong. I was going to say, yeah, actually, no, it's right. If we were to, for example, add a new gem to our project, then when we run the build, it would do a pull from the registry cache and it would say, okay, there's an image here already. We'll just use that. But it wouldn't it would just use the existing image. It wouldn't build a new one. But it should build a new one because we've changed something. And so our cached image is now invalid and we need a new one. So that's another case we'll have to address. Okay, all these passed, and wow, look, it now takes as little as 2 minutes and 25 seconds or even 2 minutes and 3 seconds. That is wonderful. Okay. So now with we've got about 20 minutes left. Let's address the case where there is no image in the registry. Okay. So first of all, how do I delete an image from a registry? I don't know. How can I delete this image from my registry? Okay. I don't know if this is going to work or not. So let's see. Oh, that's just changing the config. Okay, get the digest of the image tag. Okay. I wasn't expecting that. Okay. What is the digest though? Is this the digest? Like that? I'm going to do this. I'm going to do this curl, put it in the clipboard. I'm going to say which part is the digest. Okay. 963, blah, blah, blah. Okay. I'll just try it. I mean, if it doesn't work, then like no real harm. Okay. So digest goes there. Copy this. Operation is unsupported. Not too surprising. Okay, so instead of like configuring it to work and all that stuff, I will do something different instead. Um, okay, I'm gonna open up my job script. And I'm gonna say this. I'm gonna say, how do I make it so that, how do I make it so that, how do I articulate this? Okay, we want to use a pre-existing image when nothing has changed. How do I make it so that it uses the pre-existing image when nothing has changed, but when the image does change, it recognizes that the old image is invalid and performs a new build. Yeah, I suspected it was going to say to use specific tags rather than just latest. Oh, interesting. You can do build dash dash pull. But I suspect the build isn't even necessary. I'm going to show it my whole script and say this. Is the explicit build step, which I currently have commented, even necessary? Because I don't think it is. If the image is frequently updated and these updates are critical for job runs, then you need to ensure that the latest image is used each time. Yeah. Pulling the image ensures you have the latest, but it doesn't handle situations where the build context or Docker file has changed locally, but these changes are not yet reflected in the image available in the registry. Okay. Man, I don't understand all that, but I'm not gonna burden myself with that right now. I need to stay on task. Okay, let me go back to my place here. Yeah, here's where I asked it how it can use the pre-existing image. Okay, so what's this all about? No, not this. What's this all about? Old commit, new commit. Where do those come from? Conditional builds based on changes. If you want to make builds more conditional on actual changes, let me think. What if just after every single test run, it does a build and push? No, that's not good. Okay. How do we know if it needs to use a new image? How do we know if it needs to use a new image? Okay, so if, for example, any code has changed at all, then it'll need a new image. But how do we know that? If anybody can help me think through this, help is welcome. Okay, how do we know if our old image is invalid and we need a new one? I'll ask ChatGPT. Okay, let's say that between one run of my script and another, some code has changed, and therefore my existing image is now invalid. How would I know about that? No, how would I know? Let's be more clear. How would I know about the change? Well, it's not. Okay, hang on. If I do it that way, then this whole solution is no good. Because the only point of doing a test run is because something has changed. So I want to use the layers of the image that haven't been invalidated yet. But I want to
But
yeah.
the layers will change only if the underlying code has changed, isn't it?
Well, hold that thought 1 second. Okay. So my understanding, Sanjit, is that like we'll have a layer for the file system contents, and then, for example, another layer for yarn and for the bundle install. So if the
Yep.
code if the code has changed, but the gem file hasn't changed and the JavaScript packages haven't changed, then we should rebuild this layer, but we should not rebuild these layers.
The
And that,
only reason is if we are trying to pull the latest version of any of the gems.
say that again.
You know, if the setting is in such a way that we are pulling the latest versions of any of the gems, because the way in gem files, sometimes the version is set up as greater than so and so value. So
Yeah.
whether it tries to pull the latest version of a gem file or not, that is something that could change, isn't it?
It's something that could change, but I think only if, I mean, what we want is that if and only if the gem file has changed, do we perform the bundle install.
Okay, fair enough.
Yeah, so just to think through it, I think like if the code has changed but nothing else, then we want to build one of these, what I'll call top layers, but we don't want to rebuild the deeper layers. So that actually gives me a little clarity. It gives me a little bit of a higher quality question to ask ChatGPT. Okay, if my code changes, but for example, my gem file doesn't change, then I need to rebuild the layer that contains the code, but I want to use the cached version of the layer that contains the gems. After I do a pull, how can I tell? After I do an image pull and a git clone of the code, I'll say of the project, how can I tell for each layer whether it's safe to use the cached version of the layer or whether I need to rebuild that layer? Yeah, that's the question I want to ask. Okay, let's do something here. Yeah. All right. So I think I commented out my push step. Yeah, I did. But I'm going to move the push to the end. Yeah. So no matter what, we're going to push at the end. That way, the image in my registry cache will always be up to date. So then every time we do a pull, the image that we're pulling will be at most one commit out of date. And so we can see, has anything changed since this last one? Layer by layer. And if so, for that layer, then we need to rebuild it. And if not, then not. But Docker Compose, I understand, will be smart enough to do that itself. Okay, so I'm going to do this. Why did gemfile.lock change that? That's irrelevant. Okay. Yeah, so I'm going to say bring back push step. Okay. All right, and so that'll take 2 or 3 minutes, I expect. Let me think. Okay, so nothing in the repo has actually changed. So after we do the pull on this particular run I'm talking about, it'll do a pull and then it'll do a Docker Compose run. But since nothing has changed, it doesn't have to rebuild. It can just use the image that we just pulled. And then at the end, it'll do a push, which is actually pointless this time around because it's just pushing the same image that it pulled. And so this run is pointless. We don't need it. All right. So what I want to do now is I want to change the code and I want to do another run and I want to see if I change the code and do a test run, does it do the wrong thing and still use the cached image, or does it do the right thing and does it perform a fresh build? Let's find out. So I'm going to change a test. I'm just going to grab an arbitrary test. Got some coming through in the chat. Guillaume says, I suspect the gemfile.lock to change because the bundler doesn't have the same version as the image. The bundler doesn't have the same version as the image. The bundler doesn't have the same version as the image. I don't understand.
It's because, you know, when you install, sometimes at the end of the gem file lock, you see a bundled with, and you see the version of the bundler. And I feel like if, for example, here you did the install on your laptop and you saw on the Git difference that the gem file lock has changed, and even if you didn't change anything on it, and it means something is changing the file, so it invalidates the cache.
I see why I didn't understand. I maybe did it fast enough that you missed it, but I actually blew away that change. I didn't commit it.
Oh, okay.
Yeah. So I think we should be good in that regard. Okay. So right now this test passes, or at least I expect that it will pass, but I'm going to change it so that it fails. And there we go. So I'm going to say expect true to equal false be false. Expect true to be false, and obviously that is going to fail. Yep. All right, so I'm going to say intentionally make test fail. Okay, so now the question is, will the build do the right thing or the wrong thing? Okay, so how can we productively use this next 2 or 3 minutes while we're waiting for this to finish? So what cases are we needing to address? We're needing to address the case where the code changes. Basically, there's two scenarios. When the code changes, we need to do a build. No. Okay. I was oversimplifying it. So our build, no. Our image has layers. Our image has layers. And for each run, each layer will either have a valid cache or an invalid cache. I was trying to think of a better way to say that, but okay. For each layer, for each layer, it'll either have a valid cache or an invalid cache. If the cached layer is valid, we should use that. If it's not valid, we should rebuild that layer. And again, yeah, go ahead.
Sorry, are we overcomplicating it? Won't the build do it for us automatically? As in, if the... Oh, sorry, go on.
I was just going to say, I don't know that we have to explicitly do anything special. Docker might just behave that way by default. Which I hope it does. You know, that would be really nice.
Yeah. My understanding is, Docker will do it automatically.
That's my understanding too, based on what I've learned up to now. Okay, so job 1 has finished, but job 2 is still running. Okay.
I think if we just copy the file, then it will stop catching at the copy code steps. So the run bundler, that will be catch, and then at the copy.code, that one will start rebuilding, because we change in that line. I mean, we change code, so when it copy, it has changed. So then after that, it will not doing the catch.
Do you mean
Line
that
12, yeah.
when it gets to here and copies the code, it'll be like, okay, I see the code is different. We got to rebuild.
No. Until line 12, I think.
Line 12?
Because we did.
Oh,
we
yeah.
didn't change.
Yeah. Yeah, it'll perform the bundle install and say like, okay, we're good. But then it'll do this step and it'll say, oh, okay, this is different. We have to rebuild. And then every subsequent layer will get rebuilt also.
Yeah. And maybe we can move yarn before we can move the updates just before we run the copy gem file. So maybe line 14 until 20, we just move up. Oh, I mean, or maybe until line 17.
Yeah.
So then it doesn't have to install yarn again.
Yeah, I think that's probably going to be a good idea. Okay, has this finished yet? Failed. Okay, failed is what we want. Okay, that is fantastic news. Okay, so I'm going to revert that commit. Oh, and we're about at time here. Okay, revert. I'm gonna run that just for fun. Okay, and then we can change our Docker file. Although I'm a little bit surprised, this ran quite quickly. But let's do this anyway. Okay. Can I change my Docker file and move the yarn steps to before copy code for more efficient caching? And I suspect the answer is yes. And I don't know if this is going to give us any benefit that we can see right now, but it at least seems logically correct to do this. Okay, yeah. Rearrange Docker file for more efficient caching. Okay, and I think we can clean up our job script a little bit. Yeah, so this comment is out of date. Pushing and pulling works, but when we do a build, it doesn't seem to use the cached image. That's not an issue anymore. This build doesn't happen. And so this stuff is now invalid. We don't even have these steps anymore. Okay. Yes. Yeah, okay. Clean up job script. Okay. So as long as I don't encounter any surprises with these couple more builds, then I think we're done. One last thing before we go. Whoops. No. There. Oh, okay. Yeah, whatever. I want to look at this branch on GitHub and just review what I've changed before I merge the branch. Although GitHub is being super slow. Oh, here we go. Registry cache. Okay. Okay, so I added this Docker ignore. Not too concerned with that. Changed the Docker file. We were working with that just now, so no surprises there. Use this image. Great. We added this Docker registry cache machine request. That's all good. Change the script to add this config. Docker push. Great. That all looks fine. And so provided this passes, I will merge it and we can celebrate, because I've been working on this now for months. Probably only a total of like 10 hours or something like that, but over a time period of months. So it's very satisfying to me to finally have this figured out. And I don't think we're done. I think we can do more to make it even more efficient. But this is a great improvement. We've basically cut the build time in half.
Yep, that's what you've been working on for a while, right? You know,
For quite a while, yeah. Yeah, so I'm just taking a look at our events here. Yeah, this pre-script takes a while to run, which like runs DB create and stuff like that. I wonder if that can be sped up in any way. Because again, the only thing that really the whole purpose of running this thing is to run the test suite, which only takes like 20 seconds. So I'm sure that we can do away with some more of this overhead. Exactly how we might want to do that, I'm not sure yet, and I won't even bother to think about it right now. We can think about that later. Okay, so that passed. This one took a little longer, 311, but that's to be expected. There is some variance. And again, I do think there's some more stuff we can do to cut down on that build time even more. Okay, so for the grand finale, git merge squash registry cache. There we go. Oh, that's weird. The current branch main has no upstream branch. That's surprising, but whatever. Everything up to date? Oh, okay. Apparently that push worked. I don't know what that was all about, but I don't care. Okay. And then the last thing I want to do is leave a note for myself for what to do next. And I know exactly what I want to do next. It's a fairly minor thing, but it's definitely important. To do next, change all instances of this IP address to registrycache.saturnci.com. That'll be, I don't want to jinx it, but that'll be simple and easy. But it's definitely a necessary step. So we'll leave that for next time. Okay, but anyway, we figured it out. We merged it. Yay! Okay, thanks a lot, guys, for joining me, and I will see you next time.
Okay, see ya.